Okay, good morning, everyone. Welcome to reInvent and welcome to Mobile State of the Union. I'm looking around this room, I'm thinking, this is the fourth time I've been here and the room has grown and the number of people in the room has grown as well. So I'm going to ask a couple of questions, just bear with me for a second. How many people are working on mobile apps? Okay. How many people are going to be working on mobile apps? Okay, you're in the right room. One of the interesting things that I've seen over the last few years at reInvent is the increasing interest of enterprises in the mobile space. So if you guys, any of you guys work in enterprises who are going to be building, let's say, business to employee apps, can you kind of stick your hands up? A few. Okay, cool. And one final question. So just multiple choice. You can put your hands up multiple times. Who's building native? Good number. Hybrid? All right. And web? Okay, good mix. All right. All right, so that's all you have to do in this session apart from listen, so thanks, appreciate it. And here's just, reinforcing, I think the room reinforces some of the trends I'm going to show you here. So I guess the first one I want to talk about, and people talk a lot about plateauing in mobile and so on, but things are not plateauing, right? 1.6 trillion hours spent in apps in 2016, an estimated 2.1 trillion hours spent in apps in 2017, and that goes up to 3.5 trillion in 2021. So there's a lot of growth, a lot of app usage happening, and I guess that's kind of representative of you guys in the room, most of whom are thinking about apps. Also, as I mentioned, the enterprise interest in building apps is growing. There's a lot of enterprises coming to us saying, well, we've got a consumer app, but we also want to build a bunch of apps for our employees, and those employees need access to our back-end services and to our back-end data that, it's difficult to get into mobile apps and so on. So we've been hearing a lot about how that space is growing and becoming more important. And finally, I think a lot of you are building hybrid and web apps, and JavaScript, I think, is starting to gain more and more popularity. 66.7% on a recent Stack Overflow survey said that they were using JavaScript, and it was the most popular language being used by professional developers in that survey. So some interesting trends, and we've been following these trends for a couple of years, and what you'll see in this session is a little bit addressing some of those areas. So our goal with the mobile services that we build is to enable you, the developers, to build high-quality apps which are cloud-enabled. We've been working on making that process easier, because one of the things we also heard is front-end developers, JavaScript developers, don't necessarily want to learn how to do distributed systems. And a lot of apps these days need to be cloud-enabled. For example, the employee apps that I talked about, but also consumer apps, they have to have access to back-end data, and they need to leverage distributed systems. So this is an area that we've been working on and iterating on over the last few months, and even longer than that. So one of the big changes we did this year was we simplified the process for building a mobile app. As you can see, we've been supporting Swift and Android for a while now. We have a service called Mobile Hub that enables you to set up your cloud services, and the native SDKs we provide enable you to integrate your native apps into the cloud. And all of this is relatively straightforward and simple to use, and you can pretty much get most apps working in a few clicks and a few lines of code. We've added a number of features to this. CocoaPods integration, for example, we've added recently. We've also added a number of improvements. For example, we have a pre-built Auth UI that allows you to add a fully working auth capability into your app with just 3 lines of code. And we've added a capability where all of the config for back-end services goes into a single JSON file that you can import into your app, and the SDK will pick it up so that you don't have various references to AWS services all over your code. So we've kind of tried to make everything nice and clean and help you guys build better apps. And now, just last week, I don't know if you guys have been following, but last week we announced support for web and React Native. We've done a couple of things. First, we've added full support for web and React Native into Mobile Hub, so you can go straight to the console and you can build for any of these 4 platforms now with a single backend. Second thing we did is we added a new CLI. Web developers, as some of you are, like to use a CLI, so we've added one. And we have made available a new library called AWS Amplify. Anyone heard of that library? A few of you? Okay, you guys should check it out. I'll talk a little bit more about that as well. So I'm just going to quickly walk through how you'd go about building a web app using these new tools. So the first step in this is you can use the CLI, and however you build your web app, whether you use create React app or any other way of setting your app up, you can initialize it for AWS Mobile using the init command. And for example, if you want to add user sign-in, you can configure user sign-in with that AWS Mobile user sign-in command. So it's like with 2 commands, you've got user sign-in set up in the cloud. As you can see on the right-hand side, we have a number of other things you can do with the CLI. So analytics, database, which is DynamoDB, files, which is Amazon S3, and the Cloud API, which is API Gateway and Lambda. All of those things can be done in the same way that you can see there with the user sign-in. Finally, for web development, we also offer a deployment option, which is via S3 and CloudFront. So you can deploy your app once you're done building it. So that's the CLI. It's, again, simplicity is there, but also the power is there. So there are a number of additional options and things you can use if you want to go into sort of more intricate setup details on any of those services. The next part is the library, which is the code that we've provided for you guys to integrate that into your app. So after you've set up the cloud services with the CLI, we've provided a JavaScript library. We've built it. We've provided it using declarative interfaces, so that it's really very simple to use. I'll show you that in a couple of minutes. We've provided the same categories as the CLI, so you can see there you've got support for auth, analytics, storage, database, and cloud APIs, and other helper functions and things such as internationalization is included there as well. So one of the challenges that we hear a lot about in web and React Native development is that some of the operations that are sort of mathematically compute intensive take a lot of time. So what we've done is we've built native bridging for React and React Native. And also we've built higher order components so that you don't have to kind of build UI and other things from the ground up. You can just use the higher order components to get going quickly. And it's open sourced and open for contributions. So if anyone wants to get involved and add to it and use it, please go to GitHub and contribute. Okay, so how do you use it? I showed you the 2 lines of the 2 commands you needed to set up the backend for sign-in an earlier slide. And here on this slide, I'm showing you the 2 lines of code you need with the higher order component to set up the client-side code. And if you want to add a 3rd line of code, you can even make it work in French. So there's the internationalization on line 7 there. You can see that. So that's basically all you have to do. At this point, you've got auth working fully end-to-end. And hopefully that's pretty straightforward for everyone. Okay, so once you've got that, the next step is testing and deploying. So here's the CLI command to publish your app into S3 and CloudFront. And at the same time, the test parameter on the end of that command actually enables you to test your website or web app on real devices. So you can see on the right-hand side the output from that. There's a couple of interesting things we provide. So the first one is the time to first meaningful paint. And for web apps, this is important. Your app is loading over CloudFront and S3, and you want to see how long it's taking on different devices. And you can see that we've provided 5 devices there. You can see the different times for the app to load on the different devices. And this is helpful if you're trying to optimize for a particular set of devices or just making sure that your app works consistently across them. And then on the bottom of that, you can see the screenshots for your app. So again, it gives you a good idea of what your app is going to look like on each of those devices and whether you need to do anything in the UI to improve it. And at this point, you're pretty much done with your app. So you've got a working web app. It's probably taken you 10 or 15 minutes and a little bit of fiddling about, but you're done. So once you've done that, you can then go back to the console. Again, the Mobile Hub console now provides you with support for all the different platforms. So let's say you've built the web client and you want to build an Android or iOS client. You can go in and add that and use the same backend. So you then have a web and an Android and an iOS client all using the same backend. And this helps you connect all of that together. And again, iOS developers don't necessarily like to use the CLI, whereas web developers do, so the console is there for developers to use. They essentially both do the same things. And in addition to supporting multiple platforms, you can also configure some of the more advanced features that are not available in the CLI yet. Things like, for example, if you want to use Amazon Lex, you can do that straight from the console as well. Okay, so we've kind of done a very quick run through of how you build an app today and the support that we have for JavaScript. But still, developers are telling us that there are issues, that there are things that they want to hear, they want to see us solve that we haven't solved yet. And one of the biggest areas for that is data. And I think if you were keen-eyed, you saw earlier on that DynamoDB was the database that we support in order for your app to kind of store and retrieve data. And whilst DynamoDB is powerful and scalable and can grow with your app, and you can build very powerful apps with it, there are a number of things that developers have to do for the mobile use cases and some of the other mobile web use cases, which are still difficult to do and require a lot of time. So I'm just going to kind of go over those things with this one. We do have hard problems that we are not necessarily making, or rather not necessarily solving in an effective way. So the first one is, when you look at the data requirements for modern apps, when you have things like, for example, an app that needs to run on a watch, and it needs to run on a mobile device, and it probably also needs to run on a website, the data requirements and the UI for each of those is different. And when that data is required to be shared across multiple users, that becomes an even harder problem to solve with things like conflict resolution and syncing and so on. Also, users want instant access to their data. They want to be able to continue using their apps when the device is offline or has low connectivity. And at the same time, they want to maintain all the scalability that DynamoDB offers without having to necessarily learn all the distributed system concept. So this is the problem that we've been working on for the last few months. And you guys get to hear it here first. We're announcing a new service, AWS Appsync. So AWS Appsync is a fully managed service for application data. We are using GraphQL in order to store and retrieve data and to handle subscriptions. It has real-time capabilities and an offline programming model. And we're going to spend the majority of the rest of the session kind of diving a little bit deeper into that. So I'm just going to lay out some of the main features of Appsync, and then we're going to kind of talk through how that works. So first of all, real-time support is important to a lot of developers. We're using GraphQL subscriptions, which are relatively simple statements in your code that enable you to tell the service what data should be updated in real time. So what do you want to subscribe to, and what do you want to see on the different devices that your users are using? The second one is, it's an offline programming model, which means that you can use your app offline. You can also add and update data offline. And then it handles all the syncing and the conflict resolution for you when the device comes back online again. The third benefit of this is the front-end developer will specify how the data is going to be structured and when it is returned from the server using GraphQL. So again, the GraphQL makes it really easy for the front-end developer to shape what data is retrieved from the server. It makes those request response to the server more efficient as well, because you're only bringing back the data you need, for example, on the Apple Watch, and maybe some different data that you need on your mobile device, and you're not dealing with kind of very rigid APIs there. The third one, which the service provides, is access to data from multiple sources. So not only do you get access from DynamoDB, but we've integrated this service with Elasticsearch and with Lambda. So you can essentially build any kind of backend that you want and provide all of that through a GraphQL interface. And that not only gives you kind of the capabilities that Dynamo gives you, like simple lookups, but you also get the capabilities of Elasticsearch, things like complex queries, the geo apps, searches, and you can do essentially anything with Lambda when it comes to retrieving data. The other benefit here is, in a single GraphQL query, you can combine the data sources. So you can combine a request which accesses data from from DynamoDB and from Elasticsearch and from Lambda, and you can get that all back into your app in a single request. And finally, we've provided fine-grained access control using Cognito and IAM, so that you can essentially ensure that you're putting in strict controls for what access users, what data users can access. And here are the kind of apps that you can build with it. And I put this up here because these are the kind of the standard suspects: so collaboration apps, social media, chat, geo apps. These kind of things are naturally fitting the full use case of GraphQL. But essentially, you know, the target is anyone who needs offline data, anyone who has any apps with multiple back-end data sources, anyone who needs real-time data, anyone whose data is a little bit complex and has complex data structures and types. So pretty much anything. And we've made it easy to use, and we're going to show you how easy it is to use. So 3 simple steps: create and upload your schema. So use GraphQL, create and upload your schema. Connect your data storage, so whatever your data sources are, you can connect them. And then wire up your clients and start using the data. And all of the configuration for the real-time and offline can be done with the console and with the GraphQL. And finally, from me, for those of you not familiar with GraphQL, it's pretty easy. The first one is a schema that you model. You can do that in our console. It's really easy to model that and test that. The second one is the client defining the query and saying, I want to see the ID, the name, and the priority. So you can see on the left-hand side, you've got essentially you've defined a table with ID, name, description, priority, due date. Your query only wants 3 of those 5 fields, and on the right-hand side, you can see that the result is just the 3 fields that you requested. So again, the query enables you to shape the data that comes back to you. So that's pretty much where we are with Appsync. What I want to do now is invite on stage Michael Paris, who's one of our lead engineers and has been working on this for a few months now. And he's going to take you a little bit deeper into this. By the way, you guys all signed up for a 300 session, so this is going to be a little bit deeper. So welcome on stage.
Thank you. How's everyone doing today? Good. Thank you, Amit, for inviting me on stage. As he said, my name is Michael Paris. I'm an engineer on the AWS Appsync team. And it is my pleasure to get to show you this service for the first time because we've been working really hard on it. So, we built the service AWS Appsync. And before I dive into it, I kind of want to set the stage. So Amit had talked about how important mobile is. There's 1.6 trillion hours being spent in mobile apps last year, more this year. There's also more devices than ever. So no longer is it just desktop applications or websites. We have mobile phones, we have tablets, we have watches, we even have IoT and smart home devices. And the commonality between all those things is that they either need to be connected all the time, or they need to have access to their data all the time, even when offline. The other shift is that there's been more services than ever. There are databases for all types of things. There's different ways to compute things with Lambda or EC2. And now you have more choices. But more choices can introduce its own set of problems. And as mobile app developers, you often don't want to be thinking about your application in terms of the back-end data structures or the databases, the indexes, the tables that make it work. You want to think in terms of the experience. So when I'm building an application, I'm thinking in terms of posts and comments, not indexes and primary keys. So first, I'm going to walk you through a really simple application. This will be on GitHub, and it'll tie in seamlessly with an application that we'll build in a second. But as you can see, it's a simple event application. It allows you to manage and create events. It allows you to comment on those events, and allows you to do it in real time and with multiple users. So here you just saw that the user clicked on Create Event. They were then prompted with a form that asked them for a name. It's then going to ask them for a when. After that, this is announcing a talk that I'll be giving later today if you guys are interested. It then announces a where and a description. And we're going to go ahead and click Save on that. So conceptually, we're dealing with some simple data structures here. We have an event model, and we have a comment model. So in the back end, they're stored in different places, though. So we have a table holding comments and a table holding events. And from our client application, to get that information and to stitch it together until now was not that simple. We were thinking in terms of hash keys, not events and comments. So here I'm just adding another event, and then afterwards, I'll add a comment. But the important part is that when we're talking about these concepts, we're seeing that data is related. And not only is it related, it's stored differently. And we still want to be able to stitch that together seamlessly to create a rich UI for our customers. When you compound this problem to all of the different devices, and when thinking about each device having to orchestrate all of the data fetching with different access patterns and libraries, the problem gets really complicated and becomes expensive to build and maintain. Ideally, we'll be able to talk about our information like I just did, like I'm speaking to you, not like an engineer. So here you can see I just added a comment. And that's great, and it all worked. So what's next? We built Appsync for a couple of different reasons. One of them was that we wanted to make it easier for you as app developers to build applications faster. And that was a key driver. We had customers coming to us and telling us that they had rich data, but it wasn't easy to interact with that data. And this leads to inefficiencies. And this is what we tackled. So let me show you how. So here is our Appsync console. The console is kind of the first place to get started. If you're new to GraphQL and if you're new to AWS, it's a really easy way to kind of go from 0 to 60 in a minute. So you're welcome to the console, and the first thing that you're going to do is we want to create an API. So we're building our event application. You saw I had a simple client application there. Let's go add an API. So I'm going to click Create API. Next, I'm going to give it a name, and I'm going to cleverly call this Event App. And then I have a choice to either choose from a custom schema, in which it'll ask me to define the entire structure of my application and wire it up with data sources that either exist or we can provision in the console later. But there's also the choice to start from this sample event schema. And here's where you're getting the first taste of GraphQL. So this is our sample schema. A schema in GraphQL defines the data model, your types, and as well as the operations that you have access to in your API. So for example, here you can see that there's this type event. It's the same event type that we used in the previous application. It has a couple fields, the ID, the name, the where, the when, the description. Then you can also see we have a type comment. Has some information about it as well that points back to the event and various other things. But then you can also see that our type event has that field comments. So despite having data stored in two different places, conceptually from the client application, I'm able to tie those concepts together with a simple GraphQL query. The last thing I want to highlight is that we've got our base operations here. So in GraphQL, you have a root schema. That schema is the entry point to your every API that you'll build with GraphQL, and it has three different types of operations. The first is query, the second is mutation, and the third is subscription. You can probably guess what they do, but query reads data, mutation changes it, and subscription allows you to subscribe to data in real time and will push that data to you over the wire. Here in our sample, we have a couple simple queries. We have get event by a single ID. We have list events. Those map to different DynamoDB calls. We have a type mutation that allows us to create an event, delete an event, and comment on events. And then we also had that type subscription that allowed you to subscribe to new comments being made on an individual event in real time. And that's powered through us. So here you saw I just click create. When I click create with the sample, Appsync goes and does some things for you. It, behind the scenes, is provisioning DynamoDB tables. It is also going to provision IAM roles that give us permission to access those data sources on your behalf. And an important thing is that these Dynamo tables are actually created in your account, which is important because you own your data, and you're able to use all of the same primitives that you're used to with AWS services. If you want to use streams, for example, you have full capability, and you get to control that lifecycle on your own. We'll just tie into it and put a layer on top. So after it finishes provisioning, as you just saw, the API is live, and it's ready to be used. So we provisioned the tables, we wired them up as data sources, we added a concept that we call resolvers, that allowed us to tie the two concepts together. And then I'm able to go to the Queries tab in the console and write GraphQL actually it has type ahead and type checking that can really make it simpler to interact with your API. So here I just called a create event mutation. That data got pushed into DynamoDB, and then the mutation itself returned exactly the data that I told it to in that selection set, which is what you call a block, including the ID, description, and name. I then went ahead and I called a get event query, and if you were watching closely, you saw as I type into this block on the left, it actually gives me type ahead and smart suggestions. And that comes because your schema is actually type checked, which gives a lot of value down the line. Not only is the schema is type checked, which gives you kind of compile time or build time checking that your network calls are going to work the way that you expect, but it also allows us to build really awesome developer tools so that you can get rich IDE integrations as well as applications like this that give you kind of a one-stop shop for GraphQL querying. And that's great. So now our application's set up, well, our API is set up. So what's next? What we're going to do now is we're going to integrate it with our application. And one of the nice parts about GraphQL is that it serves as a common interface between your API and any number of client applications that you might have in the wild. That means that you can literally copy and paste blocks of text from this editor on the left into 5 different applications of different platforms. Maybe you have an Android app, an iOS app, a React Native app, a watch. And it will work with the exact same access pattern every single time, which reduces context switching and makes it really easy to reason about your code across different platforms. So now we can kind of see that in action. In this example, we've built a React app, but I want to emphasize that this works for virtually any platform. I've seen people build IoT applications, mobile phone apps, all kinds of things. So here, the first thing you're going to do is you're going to go back to your API homepage. You're going to scroll down, and you're going to click Download. That's going to download your configuration file. You're then going to go to your text editor of choice and drag that file in, just into your source This application will be on GitHub later, and you can find it. And then we're going to import that configuration file. The configuration file contains a couple things. It contains your GraphQL URL, of which there is only one, which is actually a really nice thing. You don't have to worry about too many different URLs changing all the time. It will identify an authorization mode. The default one is API key, just so you can get started quickly without having to go and set up things like Cognito or AWS IAM. And then you're going to just import it, and it will tie in. We've built a client library, the AWS Appsync client, on top of an open source GraphQL library called Apollo Client. And the tools that we built on top of Apollo Client are what build in offline support, as well as subscription support out of the box over MQTT. So I had already done an npm install on that package, but then you just saw me do an npm start. And what you're seeing is the exact same object that I just created in the console with that single mutation. You can see that it has the same information. It's being displayed in our app. And now I'm just going to go ahead, and in the same way that I did in the previous slide, I'm going to go and add a comment reminding myself not to be late. Here we go. And we'll click Add Comment. And now to prove it to you that I'm not making this up, I'm going to jump back to the console real quick and show you the other really nice part of what GraphQL does, which is it allows you to aggregate data. It allows you to pull data from multiple data sources from a mobile app or anywhere without having to worry about where that data lives. It might be coming from Dynamo. It might be coming from Elasticsearch. You might have a Lambda calling out to a third-party service that we know nothing about. It really doesn't matter. It's up to you. You control the structure. In here, you can see that with that same get event query that before returned no comments, you can now see that I have a comment in there that I just added from the application. That's great. OK. And now before I leave this page, I don't want to get too much into the code, but I do want to show one important concept. And this is that GraphQL is a perfect match for applications that use a component model. There's a concept called co-location that basically says, I have a component. This component knows its data requirements. Maybe it's a title. It's a header that just needs a title but doesn't need the rest of the information. Then what GraphQL allows me to do is take that component's data requirements and basically alongside of it supply a single query that matches those data requirements. So I can build components without worrying about data fetching logic. I can just build my component saying this is what the component needs. And then I use a higher order component to compose a GraphQL query on top of that component. And then at runtime, the system makes sure that all of the data is available at runtime. So with under 200 lines of code, that's an arbitrary number, you can have offline support, real-time support, optimistic caching, and optimistic responses, and all of these great things, and complete control over your data model. And it's really quick. So to move on, just want to recap what just happened. So we deployed 2 Amazon Dynamo DB tables to hold event and comment records. We created 2 AWS IAM service roles, giving AWS Appsync access to that information securely. We deployed a scalable GraphQL API that comes complete with subscription support that also is handled for you out of the box. We ran some queries that interacted with data from multiple Amazon Dynamo DB tables, but we never even looked at Dynamo. And we integrated AWS Appsync with our front-end application and enabled offline and real-time support in a matter of minutes. And that's great. It was really easy to get started. But I said we had a couple incentives for building Appsync. The first was quickness and ease of use. And the second is to provide a platform that scales with the biggest of apps. And that's what I'm going to talk about real quick right now. So this is another example of an application that we built on top of Appsync. Imagine that you own a brick-and-mortar retail store, a series of stores, and you want to be aware of all purchases happening in a geographic location at any given time. And not only do you want it to be real-time right now, you want to be able to slice and dice that information so that you can look at different areas, different geographic locations, as well as different time zones or time frames. So what's happening here is we have an application. We've deployed an AWS Appsync API. that fronts both DynamoDB and Elasticsearch, and it also calls out to an AWS Lambda function that will tell us, it calls out to a third party and tells us if a payment was processed successfully or not. And what you're seeing is this entire page on both sides is satisfied with one query that's hitting all three of those data sources. As you move the red pin in the middle, it'll issue a new query, which will hit Elasticsearch again and get new geographic coordinates for the new locations in that graph. And you can also change and slice the dice with the text inputs at the top and change the radius. You can change the time span that you're looking at. Right now, I'm looking in the past 24 hours, so you can see that there's a fair amount of points. But then if I go on, I can go and change the radius, or I can go on the right and just change what I'm looking at. So let's go change it to minutes. That's the last 24 minutes. Let's change it to the last 5 minutes, and you can see that our data set chisels down dramatically. So there's your analytical purpose. You can use Elasticsearch. You have the full power of Elasticsearch at your fingertips. And from the client standpoint, I'm just talking GraphQL. I don't even know that it's Elasticsearch. And then you can see on the right, as I click around, I'm simulating a purchase event. You can imagine that as I click, it's saying, hey, I'm firing a mutation through GraphQL, the same API, saying a purchase occurred at this location. And then it pops up in real time on the left pane. So you can see that it's streaming in real time over MQTT. And that's really great. So this all took only a fraction of the time that it would have in order to stand up my own web servers and PubSub engine, WebSockets, and all the rest. And we're really excited about the future and seeing what people do with it. So just a quick cover. This is kind of what we did. So we had browser and a mobile device. There's a React Native app that goes alongside with this app. They're talking GraphQL to AWS Appsync. Appsync understands how to convert between GraphQL and DynamoDB. It also knows how to convert between GraphQL and Elasticsearch. Because we owned the data that Appsync set up for us when we first provisioned the application, I was able to add a DynamoDB stream that every time data modification requests happen on my Dynamo table, they streamed in real time to Elasticsearch and were indexed. I also had an Amazon Lambda or an AWS Lambda function that called out to a third-party service to tell me whether my purchase was successful or not. And I want to call out two important concepts here, because there's three really important ones in Appsync. There's the schema. The second one is the concept of a resolver. The resolver is, you can think of it like a function that converts between GraphQL and any of your backing data sources. So in this example, we have a resolver that knows how to talk to DynamoDB and that knows how to talk to Elasticsearch. And you set these things up one time, and then client teams never have to see them again. The other part is data sources. That allows you to have different data sources. You can bring your own or let us provision them for you like you saw in the demo. And then the last piece is we had subscriptions that were talking over MQTT. And you never had to set up any PubSub. You didn't have to set up any web servers. We handled the scaling and the connection with the MQTT brokers. And that's great. So we talked about why we think it's awesome, but I think a more compelling talk is to hear from one of our customers that's used it. So I want to introduce you to Francesca of Music Match. Thank you.
Thank you, Michael, and thanks Amazon for letting us test this new exciting service before everyone else in this room. So, but let me first start spending a few words about my company. I am one of the co-founders of Music Match. We founded the company in 2010, and our headquarters is in Italy, Bologna. And our goal was to create a new way for enjoying music thanks to song lyrics. And for this purpose, we created first a lyrics API that third-party music service can use for integrating lyrics in their own product offering. And some mobile players app for Android and iOS, and the desktop app that works on Windows, Mac, and Linux. Of course, our biggest asset is our lyrics, and we are proud saying that we host the world's largest lyrics database, both for international and local music. But as important as the lyrics are also our users, that we love to call curators. Thanks to them, we have been able to build some pretty unique tools around this kind of product. The first one was what we call synchronized lyrics. It is basically subtitles for the music. And the current coverage is something like 90% of the lyrics requests can be served with the timestamp with the music. The second product we released just 1 year ago were community-provided translation. We let our users translate the music, the lyrics in their own language. And it has been such a big success that we have, for the most popular song, translations available in more than 60 different languages. And from the point of view of coverage, we are able to provide the translation 70% of the time, at least in one language. And the last product that we are going to launch, and it is currently in beta and available only on iOS, is word-by-word synchronization. And we are going to release this also for the other platforms later next year, and using the tools that we are discussing here in this session. But of course, we are not only a music player. We also have a component in our mobile app, in our desktop app, that is able to detect the music that you are playing with your favorite music player and display the lyrics on top of that with the user interface that we call the floating lyrics. And thanks to that, we are able to collect a billion of music playback data points per day that they represent a pretty unique data set of music consumption across different applications, different music services, and different devices, because we are both on desktop and mobile. And to further improve this data set, we are going to create new tools for our users in order to categorize the music they are listening to in terms of mood, meaning, structure of the song, so identifying part with duets, so male voices, female voices, and so on. And at the end of the day, this will be a pretty unique data set that will profile our real musical taste, user taste. And in terms of user base, we assisted a steady growth in the last 7 years, both in terms of download and monthly active users. As you see in the map, where darker areas represents more sessions, we have to run a global business. And of course, AWS has been fundamental in provisioning the resources where we were needing them. But, and also elastically during each single day. If we look at peak time, we have to handle something like 400,000 requests per minute. And when the traffic gets lower, we have to handle like 200,000 requests, and in a different geographical region. And for this reason, for keeping costs down, has been fundamental elastic provisioning of our virtual machine. But there is a trend that I like to share with you in the last 4 years. And it is evident if you look at the split spending between what we spend in virtual machine and what we are spending in platform as a service. If you look at that, when we started the company, we basically thought that it was a good idea to deploy as many things in virtual machine as we can, because staying close to the bare metal was a way for us to we thought to keeping costs low. But at the end of the day, even with 30 million users, we are not able to optimize everything. And so we discovered that even if our business was increasing 10% in these 4 years, and we were sustaining some costs for migration, at the end of the day, we were spending, the total spending was going lower and lower during this year. And so the lesson we learned was not being scaring with the engineering, especially if there are new tools and technology that can you help in that. And so we started in these days to look for new mobile development tools and new mobile cloud managed services that can help us to build, simplify our mobile development on one end, and also reduce the time to market and the cost. And when I say new, I say new at least for us. We strongly believe in native development because we think that for standing out from your competition, you need to implement as many unique operating system features as you can. But sometimes there are some stuff that you can share multi-platform, and you have to. For example, in our case, are the tools that we give to our user for providing correction to lyrics, synchronizing the lyrics with the music, and so on. And it is not a coincidence that we had to launch the word-by-word synchronization tool only on iOS, because we haven't started yet adopting multi-platform development. And so launching a beta feature that you need to tweak on multiple platforms is a waste of time, basically. So we started looking to these tools, and our choice was for Reactive Native for a series of reasons. First of all, because it's a vibrant ecosystem. There are lots of face-space evolving tools, libraries, resources, docs over there. And the worst thing that could happen is that you are feeling lost, at least at the beginning, because, of course, you have a lot of options, and you do not know what to pick up for your own needs. And the second reason is because there are very powerful development tools. One overall is Expo. It basically allows you to develop a multi-platform application without even having a native tool installed on your workstation. We got inspired by that. We were not able to use that because it is somehow difficult to tweak and adapt to our development workflow. And the third reason why we were using this Reactive Native is because we would like to leverage our web development skill. We already have our desktop app built with Electron and React, and also our website is built using React. The most important reason is anyway, because it is pluggable in a native application. You can leave your application as is and just start building the multi-platform part with Reactive Native without changing a lot of code on the native part. And so the stack of our choice is the one that I just showed you on the slide. We have done some re-engineering, so we started liking type-safe languages like TypeScript. And for sharing the code both with the web part and the Reactive Native team, we started using a small toolkit called the React XP. There is another option called the Reactive Native Web, but we felt it difficult to manage by us, so we went for React XP. And at the end of the day, we built our own workflow with the ngrok for allowing web developer working on Reactive Native, not caring about building every time the native app. And so this is on the mobile development side. On the backend development side, we started looking at new cloud managed service and, of course, Appsync that Amazon is releasing today. And the idea is to using it for creating what we call a multi-device experience. Most of our users are already doing that. They start and they discover our app on their mobile phone. And then when they wish to contribute, for example, a long translation or some other content to our platform, they move by their own to the desktop or to the website. You know, a keyboard is much better for writing text. So we consider that we already had in our app built a sort of app-to-app communication mechanism. It is at the base of the feature that I call the floating lyrics. And basically it works like an external app can deep link our app, creating a custom protocol URI with its own player state. And then we are able to display the lyrics going on from that. So what we needed to extend this in a multi-device scenario was a sort of messaging bus, real-time messaging bus for exchanging this custom protocol URI between the devices that the user was sharing. And there are some open source tools that you can use for doing that. We tested in the past SignalR and Socket.io. But at the end of the day, dealing with mobile connection reliability and state synchronization is really hard to do if you have to support different platforms, different languages, and so on. So at the end of the day, we decided to test Appsync on this scenario. So the demo, the prototype that we built starts with the consideration that our users discover our apps on the mobile app stores. And I said to you that we would like to integrate with the operating system as much as we can. We don't want to abandon this stuff. So the first thing was leveraging a Windows operating system special feature called the Project Drone that basically lets you install your application on a Windows device from an Android device, just logging in with your Microsoft account. After that, we started using Appsync for saving the mobile player state in the cloud and leveraged its subscription mechanism for making this state flow till the desktop. Of course, this is just a prototype. In a real-world scenario, we would like to implement also some kind of bidirectional player control. And we try to keep all the change minimal. So the GraphQL type that we are going to share through Appsync is just the standard custom protocol URI that we are using for app-to-app communication with an envelope that represents the user ID and the device ID. So let's see how we integrated the code. If you already are using GraphQL, the integration is really simple, as Michael has shown a few moments ago. You just need to import the libraries, both for Appsync and AWS. And if you like to also to have offline support, there is a related component that you can use. After that, the second step is just configuring the SDK in your code, as you see here. Everything else will be standard GraphQL development with declaration of subscription, query, mutations, components, the connection between your component with the React Apollo component through some helper methods and so on. And at the end of the day, you will have to just decorate your component with the Apollo provider tag, giving it your client, the Appsync client, and the Appsync storage instances. So the prototype we built is in this video. And on the left, you see our mobile application that is casting from a real device the screen on my development workstation. And the other two windows are from the desktop application. The middle one is just for debugging, for seeing what is flowing. So I say that I wish to move the player state, so I'm just starting playing some music on my mobile phone. And you see in the sidebar the option I told you. So an option for installing through a native SDK the app on Windows, and an option for sending the state to the desktop app. Now the state is flown to the reactive native part, actually, and only when I click on send to desktop, a mutation is invoked, and the subscription wakes up the middle window here, and the state is used by the window running on desktop for configuring the lyrics displaying experience over there. And if I go back on the mobile phone, you will see that both the players are running in sync. There is a slight delay because, of course, the mobile phone is casting through Wi-Fi its own screen on the desktop. And so, of course, this is just the first step in the integration of Appsync in our scenario, but a very promising one because we have been able to very easily build this kind of integration. Then I'm giving the word again to Amit. Thank you.
Thank you, Francesco. It's great to see what you've been able to do in such a short time using our beta release and hacking through that with us. So appreciate your work in that, helping us make the product better. Just to wrap up for this session, couple of things. First of all, Appsync will be available later today as a preview. I strongly urge everyone who's interested in this to go and look on aws.amazon.com/appsync. Also check out the other things I talked about. So the AWS Amplify library is available on GitHub. You can see the link there. And the Mobile Hub and CLI improvements and JavaScript support that we're providing there, you can check out at the mobile site. So please go and take a look. We are available for some questions outside those doors if anyone wants to talk to us. And one other thing, for those of you who want to dive in and do a little bit of kind of detailed look at any of the things we've talked about here, there are 3 other sessions later today, much more during the week, but 3 of them later today where you can really go into the details. First one about hybrid and web apps, the second one, the last 2 around AppSync and what you can do with it. So encourage all of you to take a look. Thanks again for attending, and enjoy the rest of reInvent. Thanks.